Hello, and welcome to my PlatformCon 24 talk called Love Letter to Legacy. My name is Gerald Benischke, and I'll be challenging you to think of legacy as something other than a swear word. Now, in our industry, we've come to think of legacy code as something to be avoided like the plague. But let's start. First of all, I'd like to start looking at what is legacy code. Is it just old systems that we can't wait to get rid of? Is it just mainframes? Is it just COBOL? Well, I'd like to take a leaf out of Michael Feather's book called Working Effectively with Legacy Code. He said the main thing that distinguishes legacy code from non legacy code is tests, or rather a lack of tests. With tests, you can make things better. Without them, you just don't know whether things are getting better or worse. Let that sink in for a moment. The problem is that you can't test it. Now, I spent 25 years as a developer. I more than once came across an old piece of code in an old repository, probably not GitHub, that's too new. Might not even be in source control at all. Could it be in a zip file? And then you start asking question, well, does it actually match production? So what does that mean? We've got no automated tests. That makes changes difficult. We're not making changes. Well, how do we fix bugs? How do we fix security issues? How do we fix those UI bloopers? Not even mentioning enhancements. This is all based on tests. Now, of course, it's not just tests. Tests usually mean a build pipeline, maybe some automated deployments, maybe some continuous integration. Is that really realistic for a legacy system? Let me just rewind to what Michael Feathers is saying. Code without tests is legacy code. Now, I'd like to qualify that a little bit. First of all, code without tests that you can trust is legacy code. The question really is, can you trust the tests? Just having a folder called test is not enough. Now, I often have come across issues when you lift and shift a bit of code from one system to the next, where the domain knowledge was with a different supplier, and it was less lift and shift, more lift and shit. You don't fix bugs, you just get something in the clouds, for example. And we didn't know whether we were delivering the right thing because the tests were missing. But it's even worse than that. It's not enough that you've got tests that you can run. If your colleague can't run it, or if your colleague doesn't understand it, then that's not good enough. You don't fix one knowledge silo by hoarding knowledge ourselves. Now, I think agile ways such as pairing and continuous integration is really useful there. Now, I've cleverly in the last few slides introduced some classic cars, and my point is classic cars are really valuable. But what about classic services? Now, sometimes you have to agonize over names. It happened to me in one engagement where we actually called ourselves classic services. I've heard of the term vintage services before, but I think that's just ridiculous. Anyway, let's remind ourselves, legacy systems are very often the kind of things that make money, that add value, that make something run. Think of any government department, any banking, any insurance. I'm not sure how your organization works, but I'm sure there's usually a ton of legacy systems that actually make a system work. Dig far enough under the shiny web layers, and you very often find a mainframe or some Java code. Now, I remember Java code when it was Java 1.0, but let's not go there. Legacy has a bad name, but really, what does it tell you when a legacy system has been running for 12 years. It actually means this system has been providing value to the business for 12 years. Now, I'm not saying that we should hang on to legacy systems forever, but we mustn't lose sight of what they are. Now, we've identified what legacy systems are. Now, next, I would like to see how much worse it can get. Who sees any of those statements and finds them familiar? We've got an outdated tech stack and gaffer tape holding together the code. Why, oh, why am I on support again? The biggest problem of legacy, I think, is the reputations. Engineers are not excited by it. Usually it's an old language with old frameworks, and recruiting isn't easy. Who wants to pick up that old code? Who wants to maintain that legacy system? It doesn't sound sexy. It's a bit of a chicken and egg situation, which I like to call the maintenance death spiral. Now, it doesn't matter where in the spiral you start. If nobody wants to touch it, it means there's a lack of improvements. That in turn means that nobody wants to work on it, which means that you get a high churn of people, which leads to poor system knowledge. I think separating ops and run is a bit of a problem here, or when you have outsourcing. People who make changes should know the system. Now, there is a way out of this. It's called you build it, you run it. But it's very tricky sometimes to introduce build it, you run it into a legacy system. I mean, after all, nobody creates legacy code intentionally. But what happens when you shop around for suppliers, when you don't have any incentives to train your replacements, when the new supplier comes in and competes just on cost and there's pay cuts for experienced engineers? Now, I take a little sidestep here. We've looked at some of the problems, but I'm not done yet. I think one of the issues is one of language. I think we're using the wrong metaphors. Now, very often when we look at software engineering, we use the construction metaphor. We differentiate between greenfield development, where it's the sunnier plans of modern technology stacks, getting lots of excited software engineers building the systems based on the best practices that everything will run itself and it'll contain no bugs. Obviously, everyone wants to work on those. On the other hand, you've got legacy, which is often likened to brownfield. Now, brownfield just sounds dirty, like an old coal mine. I think that's rather judgmental. I don't think that fits as a metaphor. But it's not the only problem. Builders and maintainers usually have two different jobs. Harking back to the construction industry, you've got the big outside consultancy, which is the construction conglomerate, which builds the houses. And then you've got Dave, the roofer, that also does bathrooms. He's your offshoring service company. They're different jobs. And that's how it's often sold. But I think it's the wrong approach. Andy Hunt and Dave Thomas said that with a garden, there's a constant assumption of maintenance. Everyone says, I want a low maintenance garden, but the reality is a garden is something that you always interact with to improve or even just to keep the same. Well, that's what software is. A lot of work usually goes into keeping things running and well maintained. Now, I heard a statistic the other day which made me sit up, which is that usually the amount of code that is in the system at the first deployment is about 20% of the code. The rest of the 80% are added during maintenance, during the evolution of a product. The gardening metaphor, I think, is better than the construction metaphor, but I don't think it's the right fit for legacy code. I'd like to look at something like a cathedral restoration. Usually, you've got the plans that are lost in the midst of time. The documentation is crap. I'm looking at Confluence there. Who hasn't found a Confluence site where 75% of the articles are out of date at best and wrong at worst? Usually, when it comes to maintaining a legacy system, the skills are just no longer available. I mean, who these days knows about assembling a war file? So it often needs almost like archaeology skills to dig out what makes things work. And there's also a bit of a fallacy that equates legacy to rubbish. You know, in the same way, you might as well say the Sistine Chapel is useless. I mean, look at it. It's rubbish. Terrible. Where's the steel and glass and smart building? Who would want that? Next, I'd like to talk about experience. Now, it is interesting that when it comes to dealing with legacy code, very often the work is sort of shunned by the experienced engineers and sort of given to the not so experienced ones because it's just keeping the lights on. But really, when you deal with legacy software, it always needs change. There's always things that need to be improved. There's legislative changes, there's regulation changes, there's changes in requirements. Now, the Louvre Palace, if I take the ancient architecture metaphor a bit further, that wasn't built with that iconic glass pyramid or the Mona Lisa inside. To be able to look after systems effectively, it needs a lot of experience and it needs a lot of work. You need to be able to unpick complex code. You need to be able to add tests and add observability, understand all the side effects of all the changes that you want to make to improve it. I don't think this is the short straw. I think you can relish getting the best out of a legacy system. And I don't think you learn those skills in a feature factory. So, what do we do? How do we approach software engineering? I think software engineering with a legacy software, I think you have to approach it in the same way that you build any other software. You need to organize a team that deals with the legacy and you need to give them autonomy. The two pizza rule usually comes up in these situations, but I think it's true. If you have a huge team that looks after all the software in all the legacy world, it's not going to fit. To be fair, I'm not just talking about legacy maintenance. It's software delivery in general. You know, we need to find the right engineers, which is hard, because finding the wrong engineers is very expensive. And it's also not always about the money or the mandate rate. There are often false economies in sort of bringing in the lowest bidder in order to look after a system. Engineers aren't just bums on seat that can be interchanged as well. I think in order to really get a good team together, it's important to think about autonomy and alignment. And what I've tried to illustrate here in this graph is that what you really want is a high level of autonomy and a high level of alignment. And by that I mean that people and teams need to be pulling in the same direction, but you also need to give them the agency to make their own decisions. It's a difficult balance, but it can be done. I think it can be done by being agile, and by that I mean lowercase agile, going back to the Agile Manifesto, which really drives the fact that you want to look at the working software, which in a legacy system you just don't have the documentation. So working software over documentation, people over processes. It's really important to appreciate the knowledge that somebody that understands a legacy system brings, and that when that one engineer that still can code COBOL leaves, that you're in trouble. It helps when you think of a legacy system not as a project or as some chore, but as a product. It helps leaving the badge at the door. By that I mean that it doesn't matter whether you've been brought in as an outside consultant or whether you work as a full-time employee. When you deal with a system, you deal with the system. And this is kind of ties in with psychological safety. When anyone can voice their opinions without being afraid, then it adds the value. It adds when somebody can ask the question, says, this legacy feature, we need to keep it, even though it's old and full of holes, but we need it. And somebody needs to be able to ask those questions. Without psychological safety, we don't do that. Now, often we hear that the best thing about legacy software is just to get rid of it, because we'll just rewrite it in a new framework with modern architecture and everything will be fine. And usually that ends in tears. I'm reminded of an article that Joel Spolsky wrote ages ago talking about exactly that. The example, I think, was the Mozilla browser, which was rewritten as Netscape, a hugely long project that then meant that we got Internet Explorer because it took so long. The kind of statements that you often hear is that do it properly. We consolidate our tech stack. We just have a big bang replacement, or we get a new team in to build it. The thing that people tend to forget is that the existing team has got all the domain knowledge, which to me means that usually if you do a big replacement, just don't do it. It's always difficult to replace a system completely. It's much better to do it in lots of little steps, slice it and dice it if you like. Sometimes the only way to deal with legacy systems is to replace them. I'm not saying that the legacy system needs to live forever, but we need to take care on how to replace them. Now, I'm reminded of a certain UK-based bank called TSB that tried to replace their backend system and then had a 5-day outage. Lastly, I'd like to turn the tables on legacy. What can legacy do for you? Personally, I found that working with legacy taught me a lot of things as a developer. I learned a lot about debugging, about complex systems, about adding values, about solutions where not all of them are tactical. And I also learned that doing it in an agile way is really important. So to finish off, here we are. I hope this talk has given you some food for thought and maybe makes you think about legacy. Personally, I still would like to learn COBOL, because at the end of the day, all the people who are currently running those lovely legacy systems are aging greybeards. And when they go into retirement, maybe it's something that I would like to do and guarantee myself a lovely work. Well, thank you very much. I hope you enjoyed this talk. And that's me. My name has been Gerald Benischke, and you can find me later.